Hi, this is Arash and welcome to the Epoxy channel. In this channel, we're going to talk about the epoxy resins from the theoretical aspects to the most practical ones. So, if this is the first video that you're watching, or if you're interested in epoxy resins, please like and subscribe our channel for more videos. Thank you. Today, I'm going to present colorants, dyes and pigments for epoxy systems. Epoxies have a natural tendency to turn yellow on exposure to UV, and to cover this limitation, colorants are often used in epoxy systems. Colorants can be pigments or dyes. Dyes are rarely used in epoxy systems, and typically pigments are preferred for coloring the epoxies. Dyes are soluble and pigments are insoluble and are suspended in the medium on the binder. The particle size of dye is considerably smaller than the size of the pigment. Their other differences lies in their opacity. Pigments are opaque, whereas dyes are transparent. The other advantage of pigments over dye lies in their lightfastness. In fact, pigments have the ability to resist the fading process, whereas dyes are more vulnerable to fading or bleaching caused by ultraviolet light. The pigments are also less costly compared to dyes and are not often toxic as well. Dyes are often organic combustible compounds, whereas pigments are often inert inorganics and are relatively not combustible. In addition, often functional groups bound between dyes and substrate, where this is not the case in pigments, and typically a binder is required for pigment in the systems. In the paint and coating industry, often different kinds of fillers are used for coloring. For example, for white color, barium sulfate is used. Barium sulfate is used due to its inertness and high density. And also, for white color, titanium oxide are often employed. Barium sulfide also improves the volume and consistency, viscosity, and workability of the coating, so it is a very common one. For yellow, orange, and red coloring, different iron oxide are often used, and carbon black is used for dark coloring. Mica powder is perhaps the best pigment used in epoxy resins. It is a colored powder made from a natural mineral called muscovite, which is a silicate mineral. Before it is processed, mica comes out of the ground in large pearlescent sheets or flakes, which have a naturally shimmering, iridescent property. Synthetic fluorophlogipides are also referred to as synthetic mica. They can mimic the effect of natural mica. For example, they give a glittering finish to the makeup. Natural mica is usually an off-white mineral, but its brownish tones are also available. Compared to normal pigments, which have a matte appearance, mica is shimmering and gives a very glossy effect to the paint. Mica can be colored using various dyes and pigments to achieve the desired color. However, often these colors are not natural. Let's look at the health hazard associated to mica. Mica might be contaminated with asbestos depending on the extraction method. Asbestos is a well-known carcinogen. Mica has not shown any acute short-term health effect in humans, and the risk of cancer in humans from mica has not been proven. However, based on the studies, some of silicas are believed to cause cancer in animals. In fact, former miners, millers, and processors of mica have developed asbestosis and mesothelioma and lung cancer as a result of prolonged exposure, which might be associated to mica, asbestos, or both. Long-term inhalation of mica dust may cause lung scarring, which leads to symptoms such as coughing, shortness of breath, and weaknesses. Concerning the application, the powder pigments are cost-effective, come in range of colors, and are easy to store, but can be difficult to fully incorporate in the epoxy systems, whereas the control over liquid dyes is kind of good. They disperse well and are ideal for achieving bold colors. However, they cannot be stored as good as powder pigments. The amount of the required pigment depends on the type of the resins, pigment properties, as well as the desired color. However, only 20 to 35 grams of pigment is required for 1 kilogram of epoxy resins. The excess of pigment in the system can interfere with the curing reaction. To avoid curing imperfection, when adding pigment, often no more than 3 volume percent or 10 weight percent of pigment is used. For resin coloring, often first the resin and hardener truly mixed, and then the colorant is added gradually for the certain tint as the mixing is continued. Pigment pastes are other liquid products which are used for coloring the epoxy resins. Pigment pastes are ultra-concentrated, thick products with high lightfast, formulated especially for use with epoxy resins. The image of some pigment pastes for epoxy systems have been presented here. Acrylic paint is also one of the colorants used to tint epoxy resins somehow. Although it is inexpensive and readily available in huge variety of colors, yet it is not recommended as systems might not be compatible. The other class is azo-dyes, which are organic compounds bearing the functional group R, N, double bond N, R prime, in which R and R prime are usually RL groups. Azo-dyes are the most important synthetic colorants that have been widely used in printing, paper manufacturing, textile, and etc. Examples of azo-dyes include methyl orange, methyl red, Congo red, phenyl orange dye, etc. Azo-dyes are colored because they are conjugated systems containing altering single and double bonds. This creates area of delocalization above and below the plane of the molecule and consequently results in different colors. Azo-dyes can be carcinogens. Some of them can be carcinogenic without being cleaved into aromatic amines, whereas the carcinogenicity of some azo-dye is attributed to their cleaved product, for example, benzodiene. According to current EU regulation, azo-dyes based on benzodiene, 3,3' dimethoxybenzodiene, and other products classified as carcinogens. Azo-dyes may contain any of more than 20 well-known carcinogenic amines, which have been kind of hindered in China, Japan, India, European Union, and other countries as well. Azo-dyes could be contact allergens too. The SCS document of these colorants should be referred to when they are supposed to be used. Thanks for your attention to this video. I hope you enjoyed it. Please share your thoughts, questions, or comments on this video. See you soon.